गुड मॉर्निंग स्टूडेंट्स। आज का हमारा टॉपिक है इलेक्ट्रोकेमिकल चेंजेस। दो तरह की इलेक्ट्रोकेमिकल चेंजेस हो सकती हैं, एक जिसमें केमिकल एनर्जी को यूज़ करके इलेक्ट्रिकल एनर्जी बनाई जाती है। इस तरह की सेल्स जिसमें केमिकल एनर्जी को इलेक्ट्रिकल एनर्जी में कन्वर्ट किया जाता है उनको हम कहते हैं गैल्वेनिक सेल्स। और दूसरा है कि नॉन स्पॉन्टेनियस रिएक्शंस हैं और इलेक्ट्रिकल एनर्जी का यूज़ करके हम केमिकल रिएक्शन करवा रहे हैं। इस तरह की सेल्स जिसमें हम ऐसा करते हैं उनको हम इलेक्ट्रोलिटिक सेल्स कहते हैं। सो द इलेक्ट्रोकेमिकल सेल्स, these are the devices in which chemical energy of spontaneous redox reaction is converted to electrical energy. For example, zinc reacts with copper ions to form zinc ions and copper. This reaction is the basis of Daniell's cell, which was invented by John Daniell in 1836. Electrochemical cells are also known as galvanic cells. In electrolytic cells, on the contrary, the devices in which the phenomenon of chemical change takes place by the passage of electrical energy from an external source. So sodium chloride cannot itself convert to sodium and chlorine, but when we pass electric current through it, the electrical energy dissociates NaCl into sodium and chlorine. We'll know more about electrochemical cell. Electrochemical cell is a device in which reaction is carried out between a metal capable of giving electrons and another one which is capable of accepting electrons, and because of the chemical reaction electrical energy is produced. तो ये हमारे सामने इलेक्ट्रोकेमिकल सेल की एक एग्जाम्पल है। This is a typical simple galvanic cell. इसमें हमने जिंक रॉड को जिंक सल्फेट सॉल्यूशन में डाला है जिसकी कंसंट्रेशन हमने ली है 1 मोलर. Zinc rod is put into zinc sulfate solution and similarly copper rod is put into copper sulfate solution, again of the molarity 1 molar. The two electrodes are connected by means of an insulated wire having a key and an ammeter. When anode zinc has a greater tendency to give electrons, so when the key is put in and the circuit begins, the zinc gives its electrons, which the electrons flow through the external circuit and result in the ammeter to show a deflection. Because of the flow of electron, a current is produced. Conventionally, the direction of flow of current is opposite to the direction of flow of the electron flow. The circuit is completed by presence of a inverted U-shaped tube, which is filled with KCl or KNO3 or an ammonium nitrate. Those electrolytes are selected in which the mobility of both the cation and the anion are same. This concentrated solution is put in a agar jelly and filled into this U-shaped inverted tube. The cotton plugs are inserted at the two ends so that the two solutions do not mix into each other. This apparatus, salt bridge, helps in completion of the circuit. So electrons flow from zinc to copper through the wire, and ions can move from copper through the salt bridge into the other solution. This we will show later on. First of all, the observations that you see. Number 1 is current flows through the external circuit from copper to zinc, and electrons flow from zinc to copper. Then in this half cell, if you have previously weighed the zinc electrode, you see that gradually zinc loses its weight. The concentration of zinc ions in this solution increases as the reaction goes on. On the other hand, copper gets deposited on the copper electrode with the passage of time and its weight increases. The concentration of copper ions in this solution decreases with the passage of time. There is flow of electrons in the external circuit from zinc cloth to copper. So these are the observations. Now in explanation why these observations occur. So why zinc loses its weight? Because the zinc metal, having a greater tendency to give its electrons which are taken by the wire to copper electrode. As a result, zinc is devoid of electron. It loses its electrons and comes into the solution in the form of zinc ions, because of which the concentration of zinc in the solution increases. Similarly, copper from the solution will get attracted towards this electrode, which is having excess of electrons coming from this wire. Copper ions will take these electrons and will form copper solid, which get deposited on the electrode. So the weight of the electrode increases and the concentration of copper ions decreases in this solution. Now this loss of electrons in case of zinc, it is technically known as oxidation. So this beaker where the oxidation takes place, this is half part of this cell and is called oxidation half cell. And similarly, this beaker where reduction takes place is called reduction half cell. So this is a simple electrochemical cell. Now if this salt bridge is not put into this solution, technically initially the rate of reaction will be more, but as the time passes the reaction slowly comes to a stop and no current flows through the circuit, or in other words we can say that there is no deflection in the ammeter. So this device, this inverted U-shaped tube, which allows the circuit to be completed and allows the reaction to occur, is called a salt bridge. So definition: salt bridge is an inverted tube filled with concentrated solutions of an inert electrolyte. The electrolyte, potassium chloride or potassium nitrate or ammonium nitrate, which is put in this salt bridge has to be inert. Essential requirements for the electrolyte are: the mobility of anion and cation of the electrolyte should be almost same. The ions of the electrolyte are not involved in electrochemical change, and the ions do not react chemically with the species of the cell. As potassium nitrate or ammonium nitrate or potassium chloride satisfy these conditions, so electrolyte placed in salt bridge is one of these. Important functions of salt bridge are: number one, the salt bridge completes the external circuit, because if salt bridge is not there, the circuit breaks over here. So this salt bridge completes the external circuit. And secondly, the salt bridge maintains electrical neutrality of the two half cell solutions. This we can show that had salt bridge not been there, when a zinc electrode gives electrons and comes into the solution, the zinc ions in the solution concentration increases. The zinc ions are more and sulfate ions are less, because of which there is a net positive charge accumulated around the zinc electrode, and it will not allow more zinc to give electrons to the wire. So the reaction may tend to decrease. Reaction rate may tend to decrease. Similarly, in this half cell, when copper ions get deposited on the copper electrode, the concentration of copper ions in the solution decreases. Copper ions are less in number, sulfate ions are more, so negative charge accumulates around this electrode, because of which it will repel the electrons coming from the wire, and so again the reaction will tend to decrease. So there is no deflection after some time in the ammeter. When salt bridge is put, when the concentration of zinc ions increases, negatively charged chloride ions may diffuse in from here to electrically neutralize the excess of zinc ion. Similarly, positively charged potassium ions may diffuse here to neutralize the excess sulfate ions, and so the neutrality of the solution is maintained because of the electrolyte in the salt bridge. If you like today's video, then please do share and subscribe my video, put a like and press the bell icon so that you can get new notifications.